So in diagnosing a furnace, we need to start somewhere. Depending on what the furnace is doing, most of this furnace is in working order except for the sail switch. We'll get to that. But you need to start somewhere. So if you have this style of thermostat, an analog one, and with it off, you can check across these two to see if you have a good 12 volts there. Okay, so that's one easy way to check to see if you have voltage. Otherwise, we need to get into the furnace here, make sure we have voltage. So there's a switch back here. That's where the voltage is coming in from the battery. So with this pulled out here, I'm gonna check it right here. So we have voltage here. This other side's going to the blower, we don't have voltage there yet. So we need the blower to come on to start the process. The blower will close the sail switch and then go to the limit switch, which is back here, and then to the board. So that's telling the board that the blower's running, it's not too hot over here, it's okay to light. So spark and gas. So if we go ahead and turn the thermostat on, at this point we would not read 12 volts across here, but we could read it from here and here. Okay. Another thing I'll occasionally do is I use this is a cordless test light. So one hand needs to be touching ground, and you can see here. So you can see here we got an error. That code there is a sail limit error because the sail switch didn't close. All right. On this one here, they designed it into the intake blower wheel. All the other ones are over here. So sail switches are a big cause of failures nowadays. When they used to put the sail switch inside of here, they lasted a lot longer. So I don't know if it's the quality of the sail switch or debris getting into the switch. I've got some other videos I'll try to insert right here showing sail switches I've seen in the past. So we'll reset this here. So I'm gonna simulate this closing if this sail switch will work. And so if it does, it is, because this is the in, so we can hear it sparking now. It's trying to light. You'll hear the click from the gas valve also. Okay, turning the thermostat on. Analog thermostat. If you have a digital one like on a Dometic, there's a relay in the air conditioner board that's actually sending power down to the furnace. So you'll have a thermostat plus. And so depending on what kind of thermostat you have, this may be important or this is okay. This is the one sending the power back. What that does is trigger this relay right here, which is the time delay relay. So that's really made for when we have enough heat and we're going to turn the furnace off, it's going to keep blowing for a little while, about 45 seconds or so, to make sure it's using up all the heat. So that's what this is here for. They used to have this separate out here, so if this failed, you could change it here. Now they're on the board, so if this fails, you got to replace the whole board. Okay, so we got the blower going. Triggers the sail switch. We're checking you don't have anything across the sail switch. If you short the sail switch before the motor comes on, it's not going to work. But if we do it after, now you can see we've got spark. So that's one way to determine if you have a bad sail switch or not. You're never going to do that, jump the sail switch to try to get heat. This is just for diagging. Okay, so if we have a good sail switch, a real common problem with suburban furnaces are the connectors going to the limit switch. So you'll think you have a bad limit switch. I've had techs come up to me and say, hey, I put 3 limit switches in here, it's still not working. So obviously it's not the limit switch. I've had it be these connectors. Sometimes you can just clean everything off, push these down a little bit, or replace the pin. And I've fixed hundreds, literally hundreds of furnaces that way over the years. This turn on. Check the sail switch. Switch disconnected, so we can illustrate failure there. Okay, and then we're getting the error again over here. Okay, if we want to test sail switch resistance, I see these with really bad shape a lot of times. Put it to our ohm setting there to check resistance. Make sure you're using some kind of clips and not using your hands. And then you can see that one's showing good right there. This sail switch has been very intermittent. You can see it's all bent up. This was a poor design. So when I was originally working with this one, I could not get it to close like that. This is one from Amazon, and you can see the difference between these sails. This one looks like it's made of stainless steel. This one's aluminum. I could not get this one to work in there. It's just too heavy. Talking to Diag, they said you have to bend this until you get it to where it's going to close properly. I couldn't make the furnace light without it rubbing on that fan blade. So we can see here, it closes like so. Now, a limit switch, they're usually pretty easy to check. Check the resistance through it. So we're getting 1 ohm or an OL, or showing it's open. You know you got to replace the limit switch. Once again, on the Suburbans, you want to check that, because I always get good limit switches, but it won't light, and it's obviously not passing the current through there. Okay, so this relay closed, sent power to the blower motor. The sail switch closes. Got good power through the limit switch, and it's going to send power over to here. Right there. on the board tells the board it's okay to light. It's going to open the gas valve and send the spark. Okay, let's say we get that far and it still won't light. One thing we can check is the gas valve. So once again, we're going to check the resistance here. Ohm setting. We know this one's good. It's got 20 ohms. So these are connected together. There's two solenoids there, so if we check them individually, they're about 40 ohms. So 41 there, 41 there. Okay, and so they're hooked parallel, so that's going to cut our reading in half. So if you can get to them and check them individually, if you think your gas valve is bad, then that'll tell you, if you don't know what this total is supposed to be, which we see it is 20. If you don't know that total, check them individually. If one of them's off, probably open like this, then you know you got a bad gas valve. Another way to check gas valve, we want to make sure that we have voltage going to it. So this is not going to work with that shoulder. Volts there. So we know that the board is sending voltage to the gas valve. So actually checking the gas pressure going through here is a very advanced technique. I'm not comfortable showing that. If you suspect that's what's going on here, it probably isn't. Either these are opening and closing or they're not. That's typically what happens with these. It's rare that a gas valve goes bad. That would be an advanced technique that you would need to take to somebody that knows what they're doing. For me, it's so incredibly rare that I have something wrong with the igniter. I've only had, I think, one igniter my whole career that I had to replace. There was a crack, a hairline crack that you just couldn't see in the porcelain here, which was causing me some grief. And I think somebody had got into the furnace before me because they mentioned something about it. So it's rare you're going to have to replace these. These look pretty clean. So that's usually the last thing I'm going to check. You can usually hear the spark. If it's snapping pretty good, it's okay. Now what may be happening, which in this furnace, the burner may be a little bit difficult to get to. We'll take a look at it here. This is not a DIY process, okay? But I've seen dead rodents right on top of this thing. So if it's not lighting, once again, I would recommend replacing that gasket if you had to do that process. I'm not going to on this one because this one is getting thrown away. I'm not saving this furnace. It's just a general overview of how furnaces work and how to diagnose them. Other things I've seen so much dog hair on these blower wheels that it slows them down and won't close the sail switch. So that's another thing you need to look at. Voltage will also slow down the motor. So when people tell me it blows but it doesn't light, you know, you're going towards the sail switch or possibly low voltage. A lot of times it's low voltage. Or this has just got so much dust and dog hair on it, or pet hair on it, that it can't spin fast enough. Okay, so the wiring diagram for the furnace. 12 volt red wire goes to that switch. That's going to split off. This is going to go back to the thermostat off the blue wire. This side here goes to the circuit board. This is that time delay relay. Next is the black wire. On the old furnaces, you may see this as yellow. Goes over here to this 4-pin ground post on this one. Usually there's going to be some kind of ground post on them. One of those is going to go to the motor. This one's going to the chassis of the box of the unit. This one's going to the control board, so the control board can operate. And this one's going to the gas valve. Then this other blue wire is coming back from the thermostat when the thermostat calls for heating. And we can see here it goes to the sail switch. It piggybacks off to the circuit board. When the sail switch closes, so if the blower is turning, right, so when all that happens, it's telling the board to trigger this and send power out to the blower. The blower spins, closes the sail switch, that sends power through the sail switch and then through the limit switch back to the board. That's telling the board this is blowing, so it's cleared out the combustion chamber and it's okay to light. So at that point, it sends power out to the gas valve and to the spark.